Before the internet, communication was a slow and physical process. People sent letters that took days or weeks to arrive. They made phone calls, but these connections were temporary and could only link two people at a time. For important government and military work, this was a big problem. Imagine if a single point of failure, like a damaged phone line, could cut off all communication. Leaders and scientists knew they needed something better. They dreamed of a system that was robust, reliable, and could survive even if parts of it were damaged. This need for a stronger, more resilient way to share information was the seed from which the internet would eventually grow. The answer to this challenge came from a project called ARPANET. It was funded by the U.S. Department of Defense's Advanced Research Projects Agency, or ARPA. The goal was to connect computers at different universities and research labs across the country. In 1969, the first connection was made. A message was sent from a computer at UCLA to another at Stanford Research Institute. The system crashed after only typing the first two letters of the word login. But it was a start. This was not just about sending messages. It was about creating a decentralized network. If one path was blocked, information could find another way to its destination, making the whole system incredibly tough. The true magic behind ARPANET was a concept called packet switching. Instead of opening a single dedicated line for communication like a phone call, this new method worked differently. It broke down large messages into small pieces, or packets. Each packet contained a piece of the message and the address of where it was going. These packets would then travel independently across the network, like cars taking different routes to the same destination. They could be rerouted around busy or broken parts of the network. Once all the packets arrived at the final computer, they were reassembled in the correct order to form the original message. This packet switching technology was a revolutionary breakthrough. It made the network incredibly efficient and resilient. Multiple users could share the same network lines at the same time without interfering with each other. It also meant that the network had no central point of control. There was no single switchboard operator connecting everyone. The network itself was smart enough to manage the flow of information. This foundational idea of breaking down data into small, manageable packets is still at the core of how the internet works today. It was the first major step toward building the global communication system we now rely on every single day for almost everything we do. As ARPANET grew, a new problem emerged. More and more individual networks were being created, but they couldn't talk to each other. Each network had its own set of rules, its own language. Imagine trying to connect a phone call between someone speaking English and someone speaking Japanese without a translator. To solve this, two brilliant computer scientists, Vint Cerf and Bob Kahn, developed a universal set of rules. They called it the Transmission Control Protocol and the Internet Protocol, or TCP/IP for short. This became the common language that all computers on all networks could use to communicate with one another. TCP/IP was the key that unlocked the true potential of a network of networks, which is what the Internet really is. The TCP part of the protocol was responsible for making sure all the packets of data arrived safely and were put back together in the right order. The IP part was the addressing system, ensuring each packet knew exactly where to go. With TCP/IP, it no longer mattered what kind of computer you had or what kind of local network you were on. As long as you followed these rules, you could connect to the global system. This standard was adopted by ARPANET in 1983. A day many consider the true birth of the modern internet. For many years, the internet remained the private domain of scientists, academics, and government researchers. It was a powerful tool for sending electronic mail, or email, and sharing research files, but it was not very user-friendly. You needed to know complex commands to find anything. That all changed in 1989, when a British computer scientist named Tim Berners-Lee, working at a research center in Switzerland called CERN, had a brilliant idea. He wanted to create a simpler way for scientists to share their research papers and data. He envisioned a system of interconnected documents that could be accessed with a simple click. He called his invention the World Wide Web. It was not a separate network, but a service that ran on top of the internet. Berners-Lee created three core technologies to make it work. First was HTML. or hypertext markup language, the language used to create web pages. Second was the URL, or Uniform Resource Locator, which is the unique address for each page, like a street address for information. Finally, he created HTTP, or Hypertext Transfer Protocol, the rule that lets computers request and receive web pages. With these tools, information could be linked together. You could click on a hyperlink in one document and instantly jump to another, creating a vast web of information. Tim Berners-Lee's World Wide Web was a genius idea, but it still needed one more thing to make it accessible to everyone: a user-friendly window to look through. In 1993, a team at the University of Illinois created Mosaic, the first popular graphical web browser. Unlike earlier browsers that only showed text, Mosaic could display images alongside the text on a web page. It had a simple point-and-click interface that anyone could understand. This was a game changer. Suddenly, the internet wasn't just for experts anymore. It was a colorful, graphical space that was easy to explore. The success of Mosaic led to other browsers like Netscape Navigator and later Microsoft's Internet Explorer. The public release of easy-to-use web browsers caused an explosion of interest in the internet. Companies began to see the potential for online business, or e-commerce. They started creating websites to advertise their products and even sell them directly to customers. People started getting internet access at home, first through slow dial-up modems that tied up the phone line. The sound of a modem connecting became a familiar noise in households around the world. The internet was moving out of the universities and into living rooms. It was becoming a place for shopping, reading news, and connecting with others in new and exciting ways that were never possible before. As the web grew, it became a victim of its own success. With millions of pages being created, finding anything was like looking for a needle in a giant, ever-growing haystack. This problem gave rise to search engines. Early search engines like Yahoo organized the web into a directory of categories, like a library's card catalog. But it was Google, with its innovative PageRank algorithm, that truly mastered the art of search. Google figured out how to rank pages based on how many other pages linked to them, providing more relevant results. Suddenly, all the world's information was not just online. It was findable with a few keystrokes. The next major shift was the rise of social media. The early web was mostly a one-way street. People consumed information created by others. But platforms like Friendster, MySpace, and later Facebook, Twitter, and Instagram changed that. They gave everyone the tools to create and share their own content, their thoughts, photos, and videos. The internet became an interactive, two-way conversation. Users were no longer just passive readers, they were active participants. This era of user-generated content transformed the internet into a global social space, connecting friends, family, and strangers across the globe, and changing how we interact with each other. The internet took its next great leap when it broke free from desktop computers. The introduction of the smartphone, especially the iPhone in 2007, put a powerful, internet-connected computer in everyone's pocket. Combined with the spread of fast wireless networks like 3G, 4G, and now 5G, this meant the internet was no longer a place you had to go to. It was always with you, everywhere you went. This mobile revolution changed everything, from how we get directions and listen to music, to how we shop and do our banking. The internet became a constant companion, seamlessly integrated into the fabric of our daily lives. At the same time, another quiet revolution was happening behind the scenes: the rise of cloud computing. Instead of storing our files and running our programs on our own devices, we started keeping them on massive, powerful servers owned by companies like Amazon, Google, and Microsoft. This is the cloud. Services like Netflix, Spotify, and Google Docs all rely on the cloud. This shift means we can access our data and applications from any device, anywhere in the world. It also provides the immense processing power needed for the next wave of internet technologies, including the Internet of Things, where everyday objects from thermostats to cars are connected to the internet. Today, the internet is woven into nearly every aspect of modern society. In education, students can access online courses and vast digital libraries. In the workplace, remote work and collaboration tools allow teams to function across continents. In healthcare, telemedicine connects doctors and patients from a distance. Advanced technologies like artificial intelligence are making the internet smarter, powering everything from recommendation engines to intelligent personal assistants. These systems learn from the vast amounts of data flowing across the network to provide more personalized and efficient services, changing how we work, learn, and live. Looking to the future, the internet will only become faster, more intelligent, and more integrated into our world. The push for even higher speeds will enable new experiences like immersive virtual and augmented reality. However, this growing reliance also brings new challenges. Questions about privacy, data security, and the spread of misinformation are more important than ever. The next chapter of the internet's story will likely focus on finding a balance. We will need to build a future internet that is not only powerful and open but also safe, private, and gives users more control over their digital lives, ensuring it remains a force for good for generations to come.